Hello there once again, pre-calc students. Today we'll be working on our last lesson of this chapter 4, which is about radical equations and inequalities. Now this might be what someone might think that radicals are. That's what the term is probably most familiar connected with. However, we'll be looking at radicals in math. Now here are some important terms to know. Radical equations. Now first, right away, radical equations is where we have most commonly seen that square root. Extraneous solutions. Now these are where we test our solutions, our values that we'll solve for x, and make sure by plugging it in that they're actually real, that they actually do check out. And radical inequalities we'll see an example of that later on in this lesson. So first, turning to our radical equation, it states solve x equals the square root of x plus 7 plus 5. Now here what we want to think about doing is just getting our radical to one side. That's our first step here. So what we want to do is subtract 5 from both sides. So that would leave us with an x minus 5 equals the square root of x plus 7. Now we want to work on getting rid of that square root. To do so, we square both sides. Remember, whatever we do to one side, we really need to do to the other. So over here on the left side of our equal sign, that would leave us with an x squared minus 10x plus 25 equals x plus 7. We want to move these terms over here to the left side to simplify. That would give us an x squared minus 11x plus 18 equals 0. Now that we have it in this form, as we've been doing throughout the rest of the lessons in this chapter 4, is we can factor. When we factor this, we would have an x minus 9 times the quantity x minus 2. Still solving, we want to set each of these equal to 0. When x minus 9 is equal to 0, x would equal 9. When x minus 2 equals 0, x equals 2. Now this is where our extraneous solutions vocabulary word comes into play. We want to test that. So by doing so, we want to check when x equals 9 if it's true. So checking x equals 9. So we would have, plugging into our equation up above, we would have 9 equals square root of 9 plus 7 plus 5. Simplifying that, we would have 9 equals the square root of 16 plus 5. Square root of 16 is 4, so we'd have 9 equals 4 plus 5. 9 equals 9. This checks out, so that is the solution. Now we want to check when x equals 2. Doing the same thing as we did above, 2 equals the square root of 2 plus 7 plus 5, which would be the square root of 9 plus 5. Square root of 9 is 3, and 2 here would equal 8. However, this isn't true, so the only solution that we would have for this example would be when x equals 9. Now moving on to another step up of that same level of solving a rational equation. Here this one might look a little bit difficult since we have square roots on both sides, but we still want to think about the problem and approach it the same way as we did in the last example. So here, to try to attempt to get rid of these square roots, we want to square both sides, once again doing the same thing to one side as we do to the other. After we do that, we would have a x plus 10 equals a 5 minus the square root of 3 minus x times 5 minus the square root of 3 minus x. This is just rewriting over here what's happening on the right side. Now when we FOIL that, we would have 25 minus 10 square root of 3 minus x. Now when we take the square root times itself, remember that square root goes away. And look here, both of these signs are negative. So a negative times a negative is a positive. 3 minus x. We can simplify here on this right side. So we would have x plus 10 equals a 28 minus 10 times the square root of 3 minus x minus x. Now once again we want to work towards getting this radical by itself on one side. So we will subtract 28 from both sides and add x. That would leave us with 2x minus 18 equals a negative 10 square root of 3 minus x. Now once again, to get rid of that square root is we need to square it both sides. That would leave us with, once we factor here this left side, or FOIL this left side, excuse me, that would be a 4x squared minus 72x plus 324 equals 100 times 3 minus x. Simplifying that right side even further would be 300 minus 100x. And once again we can try to set both this right side equal to 0. After doing so, we would have a 4x squared plus 28x plus 24 equals 0. And we'll continue with this example on the next slide. Moving on here to our next slide of finishing this example, is we left off with a 4x squared plus 28x plus 24 equals 0. Now here you might be able to recognize that we can divide everything by 4. That would leave us with a x squared plus 7x plus 6 equals 0. Now once again we're able to factor. We can factor this and break this up with an x plus 6 times the quantity of an x plus 1. Once again, setting each of these quantities equal to 0. X plus 6 equals 0. We would get an x equals a negative 6. And when x plus 1 equals 0, we would have x equals negative 1. Now once again, we want to check both solutions to make sure they are not extraneous. When we check x equal to negative 6, plugging in to our initial equation, which was square root of x plus 10 equals 5 minus the square root of 3 minus x, plugging in negative 6 for x. We can simplify this right side by getting the square root of 4 is equal to 5 minus the square root of 9. Square root of 4 is 2. 5 minus square root of 9 is 3. 5 minus 3 is 2. Sure enough, 2 does equal 2, so this checks out. So that would be one of our solutions. Now here we're checking when x equals -1. Doing the same thing by plugging it into our equation of x plus 10 equals 5 minus the square root of 3 minus x. We would have square root of a -1 plus 10 equals the square root equals 5 minus the square root of 3 minus a -1. On this right side we would have square root of 9. We would have then a 5 minus the square root of 4. Square root of 9 is 3. Square root of 4 is 2. 5 minus 2 is 3. 3 does equal 3, so it does check out. So here our final solutions would actually be the ones we initially found of x equals -6 and x equals a -1. Finally, this is our last example of this lesson, which is working with radical inequalities. This radical inequality here we can see is this less than or equal to sign. Now we want to approach it the exact same way as what we've been doing for the last two examples. So if we can initially start off by squaring both sides. Doing so, on the left here we would have a 4x plus 5 is less than or equal to 100. Solving for x, 4x is less than or equal to 95. X is less than or equal to 95 over 4 or 23.75. Now one thing that's really important to know and to check is we can't have a negative square root in here, unlike what we've been doing early on in this chapter 4. We need to make sure that we're only checking real solutions. So we can't have this 4x plus 5 be negative. To guarantee that, we need to check when 4x plus 5 is greater than or equal to 0. Here we're setting it greater than or equal to 0, making sure that we're guaranteeing that it's positive. Once again, we want to solve for x. 4x is greater than or equal to -5. X is greater than or equal to -5 over 4 or a -1.25. So finally here for our solutions, it would be a -1.25 is less than or equal to x, which is less than or equal to 23.75. Now initially you might think that this is it and that we are done. However, here we need to check our solutions, and we'll actually be graphing this on a number line. So right away we'll set up our number line here. We'll count by 5, starting with -5. And here our point of -1.25 would fall right about here, and the 23.75 would fall somewhere over here. Now we need to check all of our different problems. So we need to first see what's happening when x is less than -1.25. We're looking at what's happening on our number line to the left of that point. By doing so, we can plug in and check a value such as x equals -2, since that would be to the left of our point. We can do so by plugging it into our original equation. So we would have a 4 times -2 plus 5. Want to see if that's less than or equal to 10. Here we would have the square root of -3 less than or equal to 10. However, that is false, so this does not work, so we don't need to worry about shading if it was true to the left of that point. Now let's check when we have x in between our -1.25 and 23.75. An easy point here that would just be easy on us to check would be when x equals 0, since that would be in between our two numbers. Doing the same thing as we did above before, which is 4 times 0 plus 5 less than or equal to 10. Square root of 5 is less than or equal to 10, which is true. So we would shade in between our 2 points. Finally, want to check when x is greater than at 23.75. Doing so, we can check when x equals 25. Plugging in to our equation, 4 times 25 plus 5 is less than or equal to 10. Square root of 105 less than or equal to 10. However, this is false, so we don't need to shade to the right of that 23.75. Now make sure on your number line, since it's a less than or equal to for our points, we shade in our circles. If it wasn't, if it was just a less than or a greater than, our circles would be open. That concludes our lesson on radical equations and inequalities. We'll go over some more examples very similar to these in class, just to make sure we have a better understanding of these types of problems and how to solve them. Hope you guys enjoyed the lesson, and we'll see you in class.